As Chair of the Department of Computer Science and Automation, Indian Institute of Science, it gives me great pleasure to invite you to view this video describing the fascinating journey of the Game Theory Lab over the past 3 decades under the leadership of Professor Narahari.
The Game Theory Lab in the Department of Computer Science and Automation in the division of IISc at the Indian Institute of Science, Bengaluru, India, is a metamorphosis of erstwhile Electronic Commerce Lab and before that the Intelligent Systems Lab. The Intelligent Systems Lab in the late 1980s and 1990s transformed itself into the e-commerce lab in early 2000s and subsequently became the Game Theory Lab in 2008.
The Intelligent System Labs was led by Professor N. Viswanadham and the co-investigators were Professor V.V.S. Sharma and Professor Satya K.
So, Narahari's Ph.D. thesis was on use of Petri nets, which are the new thing at that time, new algorithm based at that time, and for flexible manufacturing systems. And for that thesis, he got an award as Indian. It is considered as the best thesis of the year by the Indian Institute of Science. So, and afterwards, Narahari has taken this up and developed the Game Theory Lab, which has now grown into several other things, into agriculture and other things.
I must say the work in the lab has been driven by brilliant contributions of its 29 PhD students and more than 100 master students. During 1988 to 1996, the main topic that was pursued was performance modeling with queuing networks and stochastic Petri nets, centered around factory modeling and scheduling as the primary application. The work in the lab resulted in a textbook, Performance Modeling of Automated Manufacturing Systems, that was published by Prentice Hall, and several influential well-cited papers. During 1996 to 2004, the focus of the lab shifted to supply chain design and optimization, in tune with the rising importance of supply chain research.
Let's take a peek at the contributions of the PhD graduates in these areas. L.M. Khan's work was on using reentrant lines, a special type of queuing network introduced by Professor P.R. Kumar for performance analysis and design of scheduling policies in manufacturing systems. The thesis won a gold medal at IISc. Hemachandra's work looked at queuing systems with Markov modulated Poisson input arising in manufacturing systems and communication networks and came up with new analysis and optimization methods. K. Ravi Kumar's work was on using Brownian motion models to a difficult problem, namely scheduling multi-product manufacturing systems with setups.
Since 2005, the lab has focused on the discipline of game theory and mechanism design, working on contemporary problems at the interface of computer science and microeconomics. The lab has handpicked practically significant applications and has extended and applied relevant ideas from game theory, mechanism design, optimization, and machine learning to these applications. There are several subtopics on which the work has been carried out. The first one is on design of auctions and markets. The second one is on mechanism design for networks and crowds. The third one is on machine learning and game theory. Fourth one is on computational social choice. And the fifth one is on AI for social good.
Let's look at work on design of auctions and markets. Lakshmi Venkatapati Raju used a reinforcement learning approach to learn optimal dynamic prices in electronic markets. Shantanu Biswas designed iterative and online mechanisms for auctions and markets where bundles or combinations are traded, such as spectrum auctions and two-sided electronic markets. My work involved novel mechanisms for problems in electronic commerce. One example was to non-trivially extend Meyerson's auction for sponsored search auctions. This thesis got a Best Thesis Award in IISc. Sujit Gujar designed a new mechanism where the objects involved are heterogeneous. The thesis got a Best Thesis Award in IISc. Tirumala Nathan non-trivially extended the famous Meyerson auction to heterogeneous items, leading to 2 papers in the Journal of Mathematical Economics. T.S. Chandrasekhar took a cooperative game theory approach for procurement where the suppliers form incentive compatible coalition. S. Kameshwaran looked into a knapsack problem with a piecewise linear preferences that arises in many e-businesses applications. His thesis created a suite of algorithms for different practical settings of this problem.
We now look at the work on networks and crowds. Sopravnath's thesis was on crowdsourcing mechanisms over networks of strategic agents. Praful Chandra looked at crowdfunding for public projects and came up with incentive design for successful completion of crowdfunding campaigns. My own thesis was on game theoretic models for social network analysis, which resulted in superior algorithms for problems such as influence maximization and community detection. This work got the Computer Society of India's Best Ph.D. Thesis Award. Pankaj Dayama's PhD led to novel mechanisms for scheduling product marketing campaigns over networks with strategic agents. Swapnil Dhamal worked on new models and methods for formation and analysis of social networks.
We now look at machine learning involving game theoretic agents. Shweta Jain's doctoral work was on designing optimal multi-armed bandit algorithms where the arms are controlled by strategic agents. Satyanath Bhatt looked at mechanisms with learning to balance cost and quality in tasks outsourced to strategic agents. Divya Padmanabhan designed incentive compatible mechanisms for classical learning problems such as classification and regression, where the agents involved are game theoretic. Ganesh Ghalme looked at online platforms such as educational and Q&A platforms and came up with learning algorithms with guarantees on honest participation and fairness.
The field of computational social choice has created a buzz in the past decade. Palash De was able to resolve the complexity of several fundamental problems in computational social choice and voting, for which the thesis was awarded the ACM India Best Dissertation Award. Arpita Biswas's PhD thesis resulted in several state-of-the-art algorithms for individual and collective fairness measures. Her thesis got a Best Thesis Award in IISc as well as the Best Doctoral Dissertation Award of INAE. Shivika Narang worked on matching problems and came up with algorithms that find a fine balance among efficiency, stability, fairness and incentive compatibility. Anand designed efficient algorithms for fair division with provable guarantees. The thesis got a commendation from PMRF. Gogulapati Sridurga's PhD work was on participatory budgeting. She designed algorithms that balance fairness and social welfare. My PhD work explored fairness as well as causality in online decision making in uncertain environments.
The lab has looked at the use of game theory and machine learning models in a variety of socially relevant applications such as education, healthcare and agriculture. My PhD thesis looked into the game theoretic modeling and analysis of socially relevant applications and teaching innovations. This thesis got a prize from Xerox Research India Labs. Shaurya Roy's PhD thesis resulted in several new techniques for automatic short answer grading, a thesis in natural language processing almost 8 years before the explosion of NLP, LLMs and generative AI. Mayank Ratan Bharadwaj was challenged by Professor Narahari to work on a NABARD project where he was able to come up with game theory and AI-based algorithms for crop planning, crop recommendation, agricultural input procurement and crop price prediction. Amal Roy was able to use mean field theory and mean field games to devise mechanisms to induce socially optimal behavior from the population in an epidemic setting.
The game theory lab is all about people. The lab has sustained its action over the years with brilliant contributions from bright young students. The lab has produced 29 PhD graduates, of which 14 have taken up faculty positions including in Rutgers, University of London and as many as 10 in IITs.
The lab has produced more than 130 master's graduates who have excelled in the global industry and academia. One of them, Professor Manoj Singh Gaur, is currently the director at IIT Jammu. Several of our students have received Best Thesis Awards.
The lab has inspired many young students to spend a productive internship here. BTech and MTech graduates have worked in the lab as research engineers and project associates in various sponsored projects and have gone on to pursue higher education or high-end jobs.
Through the years, the game theory lab has had significant impact through its writings as well. In 2009, Professor Narahari and 3 graduate students composed a Springer research monograph titled Game Theoretic Problems, Applications in Network Economics and Market Design. In 2014, Professor Narahari brought out a comprehensive textbook, Game Theory and Mechanism Design, with a wonderful endorsement was written by Eric Maskin, Nobel laureate in 2007 for economic sciences. On the publication front, the members of the group have produced many notable works. These papers have been published in top-tier journals and reputed conferences.
The research questions addressed in the lab have been solidly motivated by societal and industrial problems. This has culminated in high-impact projects with global R&D companies. The research is also generously supported by government agencies such as NABARD and Bharat Electronics.
The lab has organized or co-organized a number of events including EDM 2023, Wine 2017, IEEE Case 2009, and now Game Arts.
The lab has hosted a galaxy of eminent experts such as Nobel laureate Professor Eric Maskin, Nobel laureate Professor Robert Aumann, Professor Thomas Kailath, Professor Sanjoy Mitter, Professor Christos Papadimitriou, Professor P.R. Kumar, Professor Krishna Patipati, Professor Vivek Borkar, and Professor David Parks. Their visits have ensured that the lab has always remained relevant.
The lab has prospered because of the terrific contributions of the young people and wonderful ecosystem provided by the Department of Computer Science and Automation and the Indian Institute of Science. Our thanks go out to the successive chairs of the Department of CSA for their wonderful support to the Game Theory Lab. We are grateful to the leadership of the Indian Institute of Science for providing infinite academic freedom and a marvelous ecosystem to pursue high quality and high impact work. The lab has always believed that game theory, mechanism design, and AI can be transformative for the society in areas such as agriculture, public health, and education. Going forward, our ambition would be to touch the society with high impact applications in line with the vision of Jamshedji Nusratwanji Tata, the founding father of this great institution, IISc.